Hello and welcome to this episode about me learning Kyma, my learning path to Kyma. Today we will have a little really non-trivial session about how security is handled in Kyma. So quite some things about authentication and authorization within Kyma. So there are two learning goals for me at least. One is to know and to understand which components play which role within Kyma when it comes to authentication, when it comes to identity provisioning. And second goal is how to secure API endpoints that you expose from Kyma. So if you remember all the lessons that we made, we just exposed endpoints and there was no authentication at all. And so within this session, we'll take a look at how we can make those things a bit more secure. So basically what we will be dealing with today or within this session is two main components that are delivered via the Kyma stack. One is DEX, which is an kind of an IDP proxy, and ORI, which is responsible for API rules and for Oauth clients and so on and so forth. So before we go into the code, which will be the very last part of this session, we will now dive a bit into, let's say, the theory and the concepts that are given for Kyma and how things act behind the scenes. So where do we start? We start in the documentation of Kyma. That is quite good from my point of view. And there is a quite extensive section in the Kyma documentation about security, about the components that are used there and what is delivered by Kyma out of the box. So within the introduction of the security section, there is already all the basic information there. So when it comes to the user access to functionality within Kyma, Kyma delivers some predefined role-based access control roles in order to manage the user access. So you do not have to set up all that stuff from scratch. This is basically the stuff that we dealt with when we set up our Kyma cluster, where we assigned the roles to our user, where we basically made use of the predefined roles. Then there are the next three parts that are important, that are the service-to-service and ingress setup when it comes to TLS. So we have mutual TLS here, which is set up using H2 service mesh. I will not really dive into that because, well, that's there out of the box. And there is DEX, which is the local identity provider, which also covers some federation capabilities. So in order to delegate to external identity providers, we will take a look at that. And we have ORI, which is responsible for the securing of the API endpoints. And there are two. ORI is a project that consists of several components, and the components that are relevant for us is the Oathkeeper and Hydra. So first thing we will now walk through is identity provisioning, authentication within Kyma. And here we have to distinguish several ways of how authentication happens. So the main building block for user authentication in Kyma is DEX. So all the identity federation in Kyma is managed through DEX, which is open source and which is an OpenID Connect identity provider. We will take a look into that OpenID Oauth things a bit later. And what it basically does is very well depicted here within this picture. So what we have is a user who accesses an application whatsoever, and then the application redirects to DEX, and DEX then federates the access to your identity provider. Now for Kyma, out of the box, there is a static user store that is implemented. And that is then no longer federated to another IDP. So no other IDP provider is there in the backend. And then, well, the token handling is done and you can access all the applications. This is now true for user authentication. There are two further things that are relevant in that context, and that's service-to-service authentication. So if one service calls another, this is where Istio service mesh comes into play. Here is the service-to-service authentication pre-configured and available within your managed Kyma, as well as encryption within the mutual TLS setup of Istio. And last but not least, there is the user-to-service authentication. And this is now where DEX comes into play. Because here Kmya uses this API gateway component that is using or built on top of the Ori Oathkeeper. So this is where the API rules that we already use quite sometimes come into play, and where you can do some configuration in order to do the authentication. So again, we have within Kyma already quite some things that come out of the box when it comes to authentication. When it comes to user authentication, DEX is the cornerstone in order to do that. In all the other cases, so service to service, there is Istio, which does the job. And with user to service authentication, it's Ori. That's important. Now, when it comes to authorization, there is also, as I said before, something within Kyma that helps you with dealing with access and access rules for the resources within Kyma. I think we covered a bit of that within one of the first lessons when we took a look at the different components of Kyma and what roles are there. And there we had these cluster-wide authorizations, and here you see all the predefined roles that are delivered with Kyma. And we have the namespace-wide authorizations that are only relevant for a namespace, and they kind of manifest themselves in the role bindings, where we have the cluster role binding, which is cluster-wide, and we have the role binding specific to a namespace, which is then only relevant for a namespace. So this is basically the authorization part. Again, also for authorization, we have on the one hand side for users the roles, we have on the other side for the service-to-service authorization Istio service mesh component, which supports the Istio role-based access mechanism. Whereas also some further information. And then last but not least, again, we have the user-to-service authorization, which is covered by Ori Oathkeeper. So, well, it's the same schema as for authentication. We use the Kubernetes built-in mechanisms for the access to Kyma per se. And when it comes to service-to-service authorization, as for authentication, we use the Istio service mesh mechanisms and mechanics. And when it comes to user-to-service authorization, as in the case for authentication, we use Ori. Okay, so there is also one nice section here that gives you a bit of an insight. What happens when you, for example, interact with Kyma console, or when you interact with kubectl with your Kyma cluster. So for example, for the console UI, you access your console and you are getting routed through the ingress gateway. And here again, we have DEX as part of the game that issues the token relevant for you to get the the allowance to fetch some resources. As we have already seen, our user within the managed offering has not all the roles that are necessary in order to access everything, which is simply due to the fact that we have a managed offering. And there is all the description down below, how things work together. As I said before, when it comes to user and Kmya, it's mostly handled by DEX or by Kubernetes built-in functionality. And the same goes for kubectl. So this is then the flow that happens every time you interact with kubectl. So that's basically it about the basics within Kmya. So the three main building blocks that we have there. Now, when it comes to DEX and when it comes to identity provisioning, we have already read and learned that DEX is a federated connect provider. So it is an identity service, but it also acts as a portal to other identity providers, making use of so-called connectors. So with DEX, you can delegate your authentication to other IDP providers, which would be usually the case because you do not want to have a user store within DEX, at least not that I can think of. So there is the description within GitHub that clearly shows how things work, and it's really straightforward. So we have our client app. This client app where the user authenticates itself, then goes to DEX, or the user gets redirected to DEX, and DEX then federates the access to an upstream identity provider. And this access to the identity provider is already supported for quite some, let's say, standards, and also for quite some offerings. So what we have here when it comes to identity provisioning are all the connectors that are built in within DEX. So we have LDAP, we have Saml 2.0 flow, we have OpenID Connect, and we also have, for example, access to Microsoft or to GitHub as an IDP. It's also this table here on the GitHub page of DEX connectors or of DEX itself already tells what's supported, what's not supported, what's the status. Keep in mind, it's open. It's an open source project, so even if there is a beta, I think it's already quite stable because it's only up to the project when it tells, okay, now we are through. So there's also some further information on what the status means. Now the question is, if I have now my Kmya and I have set it up or I want to install it, how can I exchange those identity providers and when can I exchange them? And as far as I have seen for the managed offering, there is no way to do that because taking a look at the documentation, there is a section about adding an identity provider to DEX, making use of the connectors. And there is one example for GitHub. There is also one for XSUA, of course, because we're in the SAP ecosystem. But here for GitHub, it basically says, okay, what you have to do in the core of your task to federate the IDP is to create a config map YAML file that tells the Kmya installer to override specific values within the installation process in order to use this, for example, GitHub connector with the client ID, with the client secret, a redirect URI, and so on and so forth. However, this should be done. Let's see if I find it. Yeah, create the override config map in the Kubernetes cluster before DEX is installed. If we have a managed offering, that's basically not possible. Now there is a second sentence. If you want to register a connector at runtime, so when everything is already in place, trigger the update process after creating the override. So one thing is this link does not work. That is given here. So I've directly jumped to the section within the installation area. And you can trigger an upgrade without, let's say, upgrading Kyma itself. So it's just a modification of the installation files. But this also means that you must have really access to Kyma per se, which is not given within the managed area. So yeah, from my perspective, in principle, or if you use Kyma in the non-managed offering, you can exchange your IDP with some configuration stuff that you have to do. You can do that before installation. You can do that during runtime when you make an update. But it's, from my perspective, not possible when you do it in the managed offering. I also think that this is due to the fact that there might be some missing links between the IDP provisioning within SAP Cloud Platform and the managed Kyma runtime, but that's just a guess by my side. So basically, when we want to learn about authentication, the thing we have to take a look at basically for users is DEX. DEX is a federated IDP provider, so we can hook in or link in other identity providers. That's possible, and there are predefined connectors for that, but we cannot do that, at least not that I have found, within the managed Kyma offering. We can do that within, let's say, an unmanaged offering that we install ourselves. So we cannot make our hands dirty in that area, but we can secure API endpoints. And that's kind of the second part that I now want to discuss about. Now, before I start and dive into the topic of ORI, I would like to kind of walk through the, let's say, the very basics, because I always have to kind of relearn them. I don't know, they do not really deeply stick to my mind when it comes to Saml, when it comes to Oauth, when it comes to OpenID Connect. So I think it's at least for me a good idea to walk through that stuff again before I dive into the topic of the API gateway, the API rules, and ORI that makes heavily use of all those concepts. So where do we start? Well, we start at Saml, at the security assertion markup language. Now, what is Saml? Saml 2.0, that's the current standard. And that's written here. I think that's a bit small. It's a security assertion markup language that defines a framework for exchanging information. So it's basically just a framework and a language that allows you to exchange information that's linked to security, so to authorization, authentication, and such things. At least that's the first impression. Now, what is Saml all about? I found a quite nice blog post about that. What is Saml and how does it work? So, what is Saml? Well, it's and that's written here again in a very nice sentence. It's an open standard that allows identity providers to pass authorization credentials to service providers. So we have kind of a separation of concerns, where we have on the one hand side a service provider, on the other hand side an identity provider, and Saml allows them to interact one with each other. Saml is an XML-based document. Okay, that's kind of what it is. And now let's see what is Saml basically used for. So Saml itself simplifies the federated authentication authorization process between the user who wants to have access to a resource, the identity provider who knows the user, and the service provider who doesn't know the user but probably trusts the identity provider. And this is what Saml kind of glues together. At least that's my understanding. So yeah, what do we have? So we have, as I said before, the service provider, we have the identity provider, and Saml glues them together. Now, how does Saml work? This is now a quite nice graphic. So I myself log on to a system, and then I try to access a website, and the service provider now checks my credentials that he gets from the single sign-on logon with the identity provider that is configured to be a trusted identity provider. And then the identity provider sends back the authorization, the authentication messages via the Saml language. And this now is checked by the service provider. And yeah, if everything is fine, I can access my CRM system. So this is kind of the basic flow, and Saml allows me to do that in a quite decent way. Now there is one other thing besides Saml that we will come across. We will not really come across Saml, to be honest, within our coding example, but we will come across Oauth. And Oauth is a bit of a newer standard, Oauth 2.0, which wants to further streamline or make the logon process a bit easier. So Oauth, as I said, is another industry standard protocol for authorization. And as it's written here, it focuses really on the simplicity to providing authorization flows. So Oauth supports several authorization flows depending on the scenario in order to authorize yourself against an application. Now, we now know that Saml is a security assertion markup language. We have this Saml 2.0 flow that glues together the identity provider and the service provider. Now, what is Oauth? Now, Oauth is again an open standard. And we will focus on Oauth 2, which is not backward compatible. So if you have really old systems where there is only Oauth 1.0, it will not work out of the box when you upgrade. So yeah, what is Oauth about? Again, it's basically the same flow as before. So I want to authenticate my user and authorize my user in order to make use of a certain API, of a web page, of an app, whatsoever. So what I do is, which is quite similar to the situation that we discussed before, I navigate to an app and or an API, and this kind of redirects me to an authorization endpoint where I have to sign in. And if this sign in is successful, I get redirected to the web API with an access token. And with this access token, I can authorize myself in order to use the API. So that's what all this authorization is about. And with Oauth, I have a bit more, first of all, a more sophisticated way how to do that. and a bit more standardized way to do that. So I have to check, yeah. So we have several components again in order to interact with the IDP with our service. And one important part within these interactions are the so-called access tokens. So these are the tokens that I as client use in order to access a resource server, so where the resources lie. These access tokens are super short-lived, so it's really a question of hours and minutes how long they are valid. So this makes things easier because you don't have to think about, oh, how can I revoke it? How can I set the expiration date afterwards? Because it doesn't matter. It's really short-living. And there are several other tokens in the corresponding area that are necessary in order to deal with the Oauth flows that we will take a look at the moment. So as I said before, we have the client, we have our resource provider, and we have an authorization server that is responsible for issuing all the tokens and cross-checking the tokens. So this is also the place where the person who is the owner of the resource gives its grant to access something. Let's see if I find the picture. Yeah, it's here. So we have the resource owner. We have the client, so the one that accesses something. This is the owner who really owns the resource. We have the authorization server, which is responsible for the Oauth handling and the token issuing and so on and so forth. And we have the resource server, which is the home of the API, where the resource owner puts all his code and so on. The interaction is, so the client obtains a token from the authorization server, and he uses the token against the resource server in order to access the API. And yeah, these are the main components in order to make that happen. So we have this access token that is short-lived. Then we have the refresh token, which is also given back to the caller in order to trigger an automatic refresh of the access token. This is a long-living token. So that's what makes your life as developer a bit easier. So you do not have to think about when is my token expiring. So if the token is no longer valid, I can I can use my refresh token in order to get a new access token. So there is a very, very standardized way how to interact with that. There are a lot of libraries out there in order to deal with all those stuff. And there are several endpoints that are offered by the authorization server. For example, the authorize endpoint, which is the endpoint where the authorization grant is given for the access to the resources. We have the token endpoint, of course, where we fetch our token. We have the introspection endpoint where we can take a look into we can validate the token. And we have the revocation endpoint, which is an option to revoke, for example, the validity of refresh tokens. Yeah, so that's kind of one part of the Oauth story. The second part is the flow. That's kind of what I already touched a bit. There are several flows how to get your token and how to hand over the token to your API, to your resource provider. Basically, there are 3 flows in place, I would say, at the day I'm recording this session, which are relevant. One is the implicit flow. That's something that's used in some scenarios, and there is no backend backend server involved here, so it's not really of relevance for us. Typically, that's a scenario that's used for single-page applications. What's more interesting for us is the authorization code flow and the client credential flow. So the authorization code flow is really the full-fledged OAuth flow, where this token interaction and all the endpoints come into play. That's the gold standard that's given here, and that's especially relevant when a user wants to authenticate. And then there are server-to-server scenarios. So if one API calls another, and this is then this is where the client credential flow comes into place. So you have as a client got client credentials, so an ID and a secure credential. And this is then what you use in order to access an API. So it's a little bit slimmer than the authorization code flow. But this is something that basically we will use when we secure our endpoint. So this is then the thing that is part of Kmya, or that is supported by Kmya. It's this, or one of these Oauth flows. Now there's one thing that you might have seen when I scrolled through the documentation, and that's OpenID. Now OpenID, for the sake of the information, is not an add-on, it's something that's built on top of the Oauth 2.0 protocol. So as a Saml, Oauth 2.0 is not it's a framework. So there are different implementations of the framework, and OpenID Connect is a layer that's put on top in order to make life a bit simpler, and in order to fill in some gaps with respect to or that are left open, or kind of can be interpreted one or the other way when it comes to Oauth 2.0. So before we now switch to Kmya, let's shortly recap. So authorization, there are different mechanisms, there are different flows that are supported in the wild, so to say. So we have the security assertion markup language 2.0, which has a specific flow, and which is a language, an XML-based language that allows an interaction between an IDP provider and the resource service. This was kind of the start of everything, and this thing evolved, or this mechanism evolved. I wouldn't say that Oauth is a successor of Saml in that sense, but this was kind of the starting point. This is already existing for quite some time. Oauth 2.0 is a newer standard, and this really wants to make your life easier with respect to development of apps, with development of APIs in a web-based fashion, and has several flows in order to do the authentication and authorization within your system, and provides you a well-defined protocol or framework to deal with that. And there are a lot of implementations of that framework. We will, when it comes to Kmya, use one of those, as we will see in a minute. And there is one further thing, and that's OpenID Connect. And OpenID Connect is another layer, an identity layer that's based on top of the Oauth protocol, which puts in some enhancements to Oauth and makes the life a bit easier. So yeah, I will put all the links into the show notes, because that's quite a not easy to digest topic. from my perspective, and especially if you're not dealing with it on a daily basis, like me, you have to look things up and basically deal with some misunderstandings that you have in the first place, in the second place, in the third place. And every time I have to implement something like that, I really have to dive into it again. As I said before, it's not part of my daily job, but it's something that you have to wrap your head around when it comes to API development at some point in time. Now, how does Kmya support us with all these things? How does Kmya leverage Oauth 2.0? Now, as we have already seen, there is the API gateway. We have taken a look at that API gateway already in a prior session. So just to remind you, this is where the API rules come into play. So this custom resource types API rules, where you can define which endpoints are exposed to the outside and how you want to secure them, which rules or which policies should come into play. Now, this access rules, as you can see here within this schema, are optional. So this Oathkeeper, which is a part of Ori, is an optional part. So as described here, there are these access rules, and this is when the access rules come into play. We really have this token-based handling that I tried to explain before. So let's take a look again at this schema here, where I send a request with an OAuth 2 token to the Oathkeeper endpoint, which then sends the token to the Ori Hydra component in order to introspect it. That was the endpoint, if you remember. That was one of the authorization server endpoints. This then validates the token, gives back if the validation was successful. Then Oathkeeper authorizes the request and simply forwards the authorization, or forwards the request, the authorized request, to the secured resource. So if this validation is not successful, you will not have access to the resource. This is where Oathkeeper and Hydra comes into play. So this Oauth flow, this token flow. There are also other ways how to deal with that. You can also use a JWT token, so a JSON Web token, in order to authenticate or authorize your request. So this is then also handled via DEX, so not via the Ori components. And basically the flow is not that different. However, it's not an Oauth flow in that case when you do JWT tokens. Okay, so let's shortly check if we have missed something. So basically within the documentation there are the available security options described here that you can use. For example, Oauth, we already saw that when we created our API rules. However, we did not really use or come across the Oauth introspection handler, for example. We always use the no-op handler. So let's see if we find some more information about the handler. Yeah, here we go. So here we have the API rules. This is what we already used, but we did not really make extensive use of that. So what do we have here? This is the description of how the file is built up, and there are several components of the file that are now of special interest for us when we want to secure our endpoints. And that's especially this area here, starting with the mutators and the access strategies. And they are elaborated here. So we have we can define different rules for different paths that are exposed. Of course, we define the HTTP request methods. That's nothing new. And then we have something like mutators, which is referencing to the Oathkeeper mutators, part of ORI. And we have the access strategies, which are the Oathkeeper authenticators. Now, I will say a word about authenticators in a second. We have 4 supported authenticator types within Kyma. We have the Oauth 2 Introspection, which is the Oauth 2 flow. And it's the flow based on the client ID and client credentials. We have the JUT flow, and we have the no-op flow that we, or the no-op authenticator, sorry, not the flow, that we used. And we have an allow authenticator. I will say a few words about that later. So these are the access strategies that we can use. So let's take a look how these Oathkeeper things work. So basically all is part of ORI. ORI is simply an implementation of an identity infrastructure and additional services for user management. This is something that we do not use. For role management, for Oauth 2.0, so for all the flows that we've discussed, and for the OpenID Connect things, which is the layer on top of Oauth 2.0. And this component, or this ORI itself, has some subcomponents. User management, which is Kratos, Oauth 2.0 and OpenID Connect, to secure the access to your applications and APIs. This is what we are interested in. That's Hydra. And the identity and access proxy, which is Oathkeeper, which authenticates and authorizes the traffic. So as we've seen, when we do a call with an Oauth flow, we have an interaction working together of Hydra and Oathkeeper. And last but not least, we have some permission role management, which is Keto. So now let's take a look at ORI. So ORI, as I said before, consists of Oathkeeper, Hydra, and so on. Let's take a look at the Oathkeeper part. And the Oathkeeper part is the central part that authorizes incoming HTTP requests. So it's kind of, you can think of it as of an API gateway kind of thing. And for those of you who have dealt with API gateways, within API gateways you have policies that you apply to the requests, where you can do manipulations on the requests, ingoing, outgoing, and where you also usually put in your security stuff. And this is exactly what ORI is all about. So you can use that as such an point within your securing infrastructure of APIs. And what's also interesting, if you're not using Kyma or ORI, you can also kind of link that into an existing gateway. So Kong probably is one of the very well-known API gateways in the Kubernetes area, but it's also possible to implement that or to link that into, for example, AWS API gateway. So you can plug in this component into other API gateways, or you can use it standalone. yeah, this is basically it. It works as an reverse proxy kind of thingy. And it has several components. What we already know is as you can see here on the left hand side, the API access rules that we have defined. And if we think back about that definition within Kyma, we have mutators and these access strategies. So we have the mutators here. Mutators are simply things that transform especially the credentials from an incoming request to credentials that your backend understands. So what you do is you put in a layer in between the incoming call and your downstream system. And you do not want to deal with all the different ways how informations come in within your downstream system, but you want to have some middle layer in between that deals with the exchange of information, with the adoption of information in order to make it easily consumable on the downstream side. And that's the idea behind mutators. This is something that you can customize within Kyma and that you can use if that's necessary. And there is the second thing that we've seen before, and that was the access strategies. That's how it's called in Kyma, and that is the Oathkeeper Authenticator component. So here we have the authenticators, and here you see, or you already recognize, some that are available within Kyma out of the box. So we have the no-op authenticator, we have the Oauth Introspection authenticator, we have JUT, JSON Web Token authenticator, and we have the allow authenticator. Now, there is no allow authenticator within Oathkeeper. And as far as I have seen with respect to the description within Kyma and the description here within Ori, it's the anonymous authenticator that is used there. So we will now focus on the Oauth Introspection authenticator, and the Oauth Introspection authenticator is handling requests that have a bearer token in the authorization header. So this is something that we have to fetch from our authorization server, from our Oauth 2 client, where we authenticate ourselves against, and which gives us back this token that we then hand back to the API. And this is using the Oauth 2.0 token introspection in order to validate the token and grant the requested scope, because when it comes to tokens and fetching of tokens, you usually add a specific scope. So you want to specify, I will access that endpoint and I want to have the option to do reads or do writes or do whatsoever. And this is kind of mixed up within the bearer token that you get when you request the bearer token based on your client ID and your credential. And that's then kind of authenticated by this specific authenticator of Ori. Here is some more description, what you can do there, what you can hand over to the endpoint, how you can configure it. We will make a really small configuration there in order to make things work. Now the next point is I need that token in order to access the API, and the API will then check that token and say, is it valid or not? Now the question is, in order to get the token, I need to authenticate, authorize myself against the, now I have to look up, against the authorization endpoint against the authorization server. And this is where the second component of ORI comes into play, and that's Hydra. Hydra is again an Oauth 2.0 and OpenID Connect provider, which implements, as I said before, there are different implementations of the authorization framework. And ORI Hydra is one of them. And this ORI Hydra then allows you or gives you an endpoint where you can create clients. And this is the point where you fetch your credentials, so your client ID and your credential, which you then hand over to the client endpoint, which then gives you back the bearer token in order to call the API. And this is exactly described here within the documentation of Hydra. So how do you create an Oauth 2.0 client? That's exactly where the first step of the token handling and the validation of the tokens is done. Yeah, here is a description of how to create it. There is a dedicated ORI or Hydra CLI. You can also do that via YAML files, of course. So I have here the GitHub repository for ORI for Hydra. And here you see you have a dedicated API, which is the Hydra ORI API. And here you can create an Oauth client, which is the one that issues you your tokens. We will do this not via YAML, but we will do it in the Kmya dashboard, because yeah, it's one or the other way, and this time we go via the dashboard. Okay, so now let's dive into the code. So we have now seen that for the for securing API endpoints, the component that is used within Kmya is basically ORI, and ORI consists of several subcomponents, and for the authentication we have two subcomponents that are relevant. One is Hydra, which from my understanding is or can provide an Oauth 2 client. So the authorization part of the Oauth flow. And then we have, besides that, the Oathkeeper part. And the Oathkeeper part is the one that acts as an API gateway where you can define rules, where you can define the strategies, how the rules get enforced, and what you expect as an authorization mechanism in order to have access to an endpoint. There are several more functionalities within Oathkeeper, but we will just use that. Okay, so now let's go to the code part, and I will basically use, I have already scrolled down, two blocks that are written by Carlos Rogan on security of simple microservices that are deployed to Kmya. There's one blog post about the creation of the endpoint, so it's really the whole story. It's a node endpoint, or two node endpoints that you can request. One is called free, one is called prot. The free one is the free one, and the prot one is the protected one. And it's a node application. The blog describes how to build the Docker image, how to deploy it to the Docker hub, and how to deploy it to Kmya, and what to do within Kmya with respect to services, with respect to API routes. This is something that we will go walk through now. And the second blog post then basically tells you how you can now access your saved up endpoint in order to have the token handling done. Now the blog posts are great, but they have all the code embedded within the blog post. So if you want to get a quick start, I have the code, including the Docker files, including a make file for the Docker files, for the Docker images, and the deployment stuff in one of my repositories. So feel free to fetch that stuff. So this is now what we will shortly walk through. So let's take a look at the code that we want to use. So what we have is a very simple file, which is a Node.js server. As you can see here, and as I already said, there are two endpoints. One is the free endpoint that returns a free silly, and one is the prod endpoint that returns some more information with regards to the to where it's running and what was the authorization header. What you have to do in order to make things run, what we did already several times, is create the Docker image. I have the Docker file here. It's really simple. Push the Docker image to the registry and then deploy it to Kyma. So I already created the Docker file. I already pushed it to the registry, so all is in place. And what I will do now is I will now deploy the service to Kyma. It's a very basic deployment, so it's just fetching the container image and it's exposing the corresponding port of the image within Kubernetes. So for that, I have created a new namespace. I will just shortly refresh that one so that I didn't time out. Yeah, it's called Secure API. As you can see, there is no deployment here. I will shortly copy that. And then I will go to the console. Let's make that a bit bigger. Let's check if you can see that. Yeah, it should be fine. So let's do, I'm here now within the directory where I have my YAML files. I have my deployment file here. So I will do kubectl -n secure API apply, and then I want to apply the deployment file to deploy the Node app. So let's do it. And while this file is deployed, let's take a look at the service file. Again, that's quite basic. So what we do is we create a service in order to expose our endpoint as a service within our namespace. So let's apply that one too. We have service.yaml. So the service gets created. Now, as I announced before, we have now the API rules. And this time we want to have a more sophisticated setup. So what are we doing? We are defining an API rule, as we did already many times, and we will apply different rules for different paths. So here we have one path, which is the free path, which has the ORI authentication handler, no op. So it's absolutely free access to this endpoint. We allow all the methods that we have defined here, and we have no additional configuration. So that's as we have done it always before. Then we have a second endpoint, which is the protected endpoint. And here we want to have a different access strategy. Here we want to secure the endpoint via Oauth. So we define a handler, which is the Oauth through introspection handler, as we discussed before. And we add some configuration for the handler. Namely, I want, if a request comes in, I want to have the scope of node safe access scope in there. So whenever a request hits this endpoint that is not authenticated at all, so that doesn't hand over a bearer token within the authorization header, it gets refused. If I authenticate myself, the corresponding bearer token that needs to be validated by the Oauth client has to be valid and has to have the required scope. And I also only allow the get method. So let's see, things should be up and running now. I have this one deployment here. I have this one pod that is up and running, and I have the service that is also available. So what I have to do now is I have to define this API rule, what I will do now. So let's apply the API rule, which will be created in a second. Now let's take a look at the API rule, which says that there is an error. That's basically true because I have already a dry run here within the same Kyma cluster, and the API rule names have to be unique within the whole cluster, not within a namespace. So simply renaming it and deploying it should hopefully do the trick, or not. No, it's still an error. This host is occupied. So what I will do now is I will simply go to my test run, go to my API rule, delete that API rule, go back, go to my secure API. Let's try it again. Okay, it was not the name. What was it then? No idea. Nevertheless, now it works. So be a bit cautious with these API rules, because you might indeed run into problems on this API rule level when you deploy identical API rules for also within different namespaces, which are usually separated, but obviously not for the API rules. Okay, so what do we expect now? We have one endpoint that is free, and we have one that has now this Oauth 2 authentication. So what I have here is I have a little request file. Where I have defined my base URL. So this, of course, the host name was identical. So I pointed with, that was the error. Now I have it. I have pointed the, I have reused the endpoint 2 times. So it's not the API rule name, it's the endpoint, of course. That's, yeah, it's Kyma for dummies, and I'm the dummy in this case. So yeah, this is the endpoint. So I hope that's a valid one, which is my base URL. And if I now do a get to my free endpoint, I get an HTTP 200 OK, which tells me, okay, free silly, that's what I expected. Now, if I do a get request to my protected, I get a 401 unauthorized. So the request could not be authorized, of course, because I did not authorize myself at all. So what I have to do now is I have to create a client in order to get my bearer token. And we will do that. And we will do that as described within the blog post. So we have here somewhere down below the Oauth client. That is where we go. So we say it's the we create an Oauth client, Oauth client for not safe app. We want a token back. We want the grant type via client credentials, so we hand over client credentials, and we have to enter the right scope, because the response type, the token, will be only then valid for this scope. And we define a custom secret, so we say secret for Auth client for not safe app. We will create that. So now we have two things that we have to note down. We have the client ID and the client secret. We have to decode it in order to hand it over, because this was encoded. And this is where I really would be happy if there would be a copy button somewhere nearby. So this was the client ID, and this is the client secret. Okay, so now we have our client endpoint that is secured, and we have our Oauth client that can give us the tokens. So now if we go through the flow, what we have to do is we have to access this Oauth client that I have defined here. You can find the URL described within the blog post and also within the documentation, which is basically an Oauth endpoint and the token endpoint in order to fetch the token. Remember, Oauth 2 flow. I have the token endpoint where I have to fetch it. I have different flows, and I use now the credential flow. So I copy in here my credentials. So what I have here now is I send a post request to my authorization endpoint, where I say I have this basic authorization. Please grant me back the client credentials for the scope, node safe access scope. And with this bearer token, so I will send now the request. 200 OK, I get an access token back. Now I fetch this access token and put that in here as an authorization. And what I do is I send it, and baba, I get a successful past security control with all the information that I handed over. So that was basically it. So what did we achieve? Let's shortly recap. So we deployed a quite simple application, an Express app that has 2 endpoints. We exposed the service, and then we created an API rule. And within this API rule, we secured one endpoint via an Oauth 2 flow with a specific scope. And in order to get the tokens, we created, based with the Ori Hydra Oauth client, where we defined a specific client for our app with a specific response type, a specific grant type. So that's what we then used with a specific scope. And we executed the Oauth flow in order to get access to the endpoint, as you can see here. So we first fetched the bearer token. We authorized ourselves with a basic in a basic way, with a specific grant type, with a specific scope that was exactly matching the client. And then we called the endpoint with the bearer token that we got back from that endpoint. And this then was validated within Kyma. And the endpoint, or we could get access to the endpoint to the resources behind that. So this was now really the first time that we made something, let's say, real when it comes to security within Kyma. Yeah, and well, that was basically it. I hope you learned some new things. I will put all the references within the show note because there is quite some stuff to digest from my perspective. And I didn't get it by the first time, so I guess you really have to dig into that and take a look into that. Otherwise, well, it's wrapping your head about it, executing it several times, doing it several times. Yeah, and then making things happen. Okay, so that was it. Hope you enjoyed it, and see you soon.